Wikicast
Podcast.
Hello and welcome to episode number 4 of the Wikicast.
Isn't it 5?
Is it?
No, it's not. It's 4. Brilliant.
Well
Great
done.
start.
This week's episode is all about earthquakes. As usual, I'm your host, Steve O'Gallagher, and again, I'm joined with my housemate, Adam Pollard. How are you?
I'm excited to be doing earthquakes
I'm
because I
stoked.
love geology and that kind of
you-
stuff, but don't know that much about it, but love it.
Yeah. You suggested we should do basically like a series about different natural
disasters, earthquakes, I find it fascinating.
So one of the things that captivated me when I was a lot younger was the idea of volcanoes and earthquakes and things like that. Tornadoes.
But you've lived in all of these places.
I lived in tornadoes and
Alaska, Japan. What's Norway? Does Norway have anything exciting? Probably not.
Northern Lights.
That's not dangerous though,
It's
is
got a
it?
nice ski
No.
slope in Oslo.
Right, yeah. Okay, but Japan and
Alaska are shitstorms for
both
earthquakes.
on the Pacific Rim, both suffered pretty serious earthquakes, as we've seen from recently.
I think Alaska's in fact suffered the greatest earthquake.
It's a good job there was no one there, though.
1964. More on that later, I guess. Have you ever experienced an earthquake yourself?
I have, but a British earthquake. So like,
Is that the one that happened like 3 years ago, 4 years ago?
When I was at uni, so about then.
I slept through it.
I was awake
Did
and
you
I
feel
was
it?
lying in bed watching Scrubs. I think.
Nice.
Yeah, a good way to spend
That's-
like good thing to be doing at 1 a.m.
Especially as a student. That's perfect.
And everything started to sort of rumble, and I was like, "That is a big truck that's going past the house," and it carried on rumbling, and I was like, "It's a very quiet truck."
It's a very long truck.
Yeah. And then as the beams above my room started going, because I was on the top floor, started going, then I was like, "That's an earthquake.
That's a tank.
That's an earthquake. That's an earthquake." And then I think I enjoyed it immensely. I was like, "Yes!"
Because you kind of knew it wasn't gonna.
Yeah,
you wouldn't die.
Yeah. We're not on a fault line.
Yeah.
Although, obviously, they can happen off of fault lines.
Yeah. Again,
We must be on like a
get
little
into.
tiny crack, maybe? I don't know.
I don't know. I don't know. I haven't seen a map of the plates.
You haven't?
I haven't. No.
Oh, well,
Oh, hang on.
I
Maybe I
have.
have. Maybe there's one.
we're not on. We're nowhere near. The nearest
There
one
is
to
one
us
here. On the
is-
old Wikipedia, has a map
Oh,
of the plates.
Well, like, from my knowledge, there's one that sort of runs through the middle of the Mediterranean,
Mm-hmm.
which sort of ends up in Greece,
There's one that goes right down
through
in
Iceland,
in between. Yeah,
Yeah.
in between the Atlantic Ocean and.
which are both really interesting plates as well.
Really?
Well, from a very, I mean, in that Iceland is getting bigger and bigger every year. 'Cause
Yeah, you said that
been
the other day.
torn apart.
So there's one. There's a. Okay, so we should explain.
Yeah.
I guess.
There's the North American plate, which half of Iceland's on.
So plates are. I mean, plates.
Oh, well, you want to just?
Yeah,
We'll just go. We'll
the
go
Earth,
all the way to.
the Earth's crust, as it were.
Yeah,
I guess
like
is-
an orange peel.
Yeah,
It's like an
and
orange.
it's got cracks in it, massive cracks, and the cracks form the gaps between the plates, the large masses that are all rock that are stuck together.
Yes.
And these are huge. There's like, I don't know, if you imagine that there are four oceans,
7.
7
No,
oceans.
7 continents. 4 oceans. Yeah, 7 continents, 4 oceans.
Four oceans. If you were to imagine, the way that the Earth is divided up in terms of land and water, it's also divided up into kind of massive.
Which pretty
Plates.
neatly fit the continents in some places.
Yeah, because I mean that one of the lines between two plates goes right down the middle of the Atlantic Ocean. It's kind of, and it also, when it goes down to Africa, it kind of mirrors the shape of Africa
Well,
out in the
did
middle of the
you
ocean.
know that the theory of tectonic plates was only really mainstream in like the 70s, the 60s?
I did not know that.
It
I
is
guess
a
how would you know?
really, really recent idea. And
You need sonar, I would have thought, to see them.
see, I'm not entirely sure how they proved it,
Yeah.
but you can kind of see it now. It seems obvious when you look at South America and Africa, and you're like, they fit together. They clearly fit together.
Hmm.
But in the 60s, they had no idea that there were tectonic plates.
Wow.
It was a complete mystery.
Wow. So every once in a while, because they are separate land entities of crust, every once in a while there's friction between them.
Well, there's different types of sort of. There are obviously
Different ways of creating
There are
an
two
earthquake.
different types of plates. First off,
Okay.
you have continental plates,
Right.
which, as you
It's
can
probably the
imagine,
land stuff.
are land masses.
Yeah.
and you have oceanic plates,
Okay.
which are plates that are predominantly ocean.
Uh-huh.
Basically, continental ones weigh a lot more
Right.
than the
That
oceanic
makes sense
ones.
because they're above sea level.
So you can have two continentals going into each other.
Uh-huh.
So if two continentals move towards each other,
Yeah.
then that would be, say, the Indian subcontinent and the sort of Eurasian plate. So Russia and India
Okay.
are currently moving together towards each other.
And the continental always try and get on top
Because
of
they're really heavy.
each other.
Well, no, because they're two really big masses, neither of them really
dominates
dominate. So what happens is the ground just buckles.
upwards usually,
Yeah,
and creates mountains.
which is what created the Himalayas.
Yeah,
And the Himalayas are actually some of the youngest mountains in the world.
that's crazy.
Spiders are older than the Himalayas.
What?
Yeah, mental, huh? Spiders have been around longer than the Himalayas.
Wow.
And they've buckled. So that's one example.
Mm-hmm.
But you could also get a continental and an oceanic plate
Right.
that move towards each other. An example of that would be the Pacific plate
Mm-hmm.
and sort of the one Japan's on. I think it's called the Nazcaran, or there's 3 plates in that area.
Okay.
But anyway, so the oceanic one isn't as strong or isn't as big, and it loses basically to the continental plate, and it gets subducted. I think it's subduction, where it goes underneath
The other place.
the other plate.
Okay.
So currently that plate is going underneath, and obviously as it goes underneath, it gets forced down into the sort of mantle, the
Yeah.
sort of core of the planet,
Yeah.
and it's hot. It's real hot,
Right.
so it melts.
It melts rock down there, doesn't it?
So it's basically, it's fuel going into this furnace, which means that there's hot magma underneath Japan trying to push its way up.
Uh-huh.
It creates like a hot zone. So not only is there the risk of earthquakes
There's also
in
I
that
imagine,
area,
a risk
that's
of
what
volcanoes.
causes volcanoes all the way
Mm.
around the Pacific Rim, because rock is being forced under other rock, melting, creating hot zones, which makes volcanoes.
Wow.
So all of the archipelagos that you see,
Mm-hmm.
that's what they've been caused by.
When I was in Alaska, they called them archipelagos.
Is that what they're really called?
Well, that's what the
What?
Americans pronounce it. It's
I
tomato,
kinda
I think.
I made my phrase. I just looked at that word and thought,
Archipelago.
I thought that's what it
I
is.
think that's what the English call it.
It feels right.
Archipelago. I can't remember.
But yeah, I mean, like the San Francisco one is also moving against the Pacific plate.
Is that what creates the Rockies? No, that's different.
The Rockies are a bit further in, I think. I mean, my American geography is pretty bad.
There's some sirens
but-
going on outside.
The San Andreas Fault, which is, what caused the big earthquake in San Francisco in like 1921 or whatever it was, that like destroyed the entire San Francisco. That is 2 plates moving sort of past each other.
Right.
So maybe that's like a classic earthquake image in someone's mind of 2 plates going in opposite directions, and every now and then they just sort of break free of each other
Yeah.
and jolt along a bit.
I imagine it's like if you were to clench both hands into fists and then put your knuckles together,
Yeah,
and then
that's perfect.
you push one hand away from you, one towards you. Your knuckles will resist.
Eventually, but
if you push hard enough for long enough, they'll go.
one will give,
and
that
that
is a big.
causes an earthquake.
But whereas the one in Japan was caused by the ground sort of one
Going
hand
underneath.
underneath the other hand, and pushing
Right.
up and then
Yeah, because what they were saying is
coming upwards.
because of the Japan earthquake, a large plate was forced underneath.
Yeah.
A large amount of rock was forced underneath, creating a slightly more dense Earth, which
Right.
makes it spin faster. It's like if you're spinning around on a swivel chair
Okay,
and your legs are out, you're going at one speed. If you tuck your legs in, you start
Wow.
going a lot faster.
that's insane.
So if the Earth's mass can go in a little bit more, the Earth spins faster, which means the days are a little bit shorter. Which is what's happened in Japan. The day is shorter by, I think it's 1.6 microseconds
After the earthquake.
after the earthquake. In that one instance, it changed the Earth's rotation.
That's insane.
And the axis has changed as well. The axis has been misplaced. The axis is the directional of the spin of the Earth.
Yeah.
Has gone slightly off center by 6.5 inches.
6.5 inches sounds like a lot.
That is a lot. I mean, in terms of what it'll do for this week and next week, it doesn't really matter. But I imagine that will, in some form, alter. I mean, maybe slightly alter the orbit of the Earth. Potentially.
But then I suppose these earthquakes happen systematically.
Yeah.
So the axis probably moves around on a rough area over time,
Yeah,
but over time
probably
it kind of
does.
evens out, and it
Yeah.
It never really shifts
Which
massively.
it's amazing that we can even measure the fact that it's been off by 6.5 inches.